Okay, so the third description is what we call the critical constant. And typically, one thing that is actually quite important is the critical temperature. And temperature below the critical temperature, gas to liquid condensation can happen upon pressure rise, compression. Okay? If you compress it, gas to liquid condensation can happen. And if you are above PC, actually, this is what we call supercritical fluid. Okay, so this is one is actually is not gas, not liquid. It's something other than that. Okay, so and then there is a supercritical fluid. The most common one that people actually consider using it is supercritical. Supercritical means essentially above the critical temperature, CO2, carbon dioxide, as a mean to actually to do something. Okay, so let me do the pictorial way. Okay, if I have this is the same thing. If I have a temperature lower than critical temperature, if I'm compressing it, you will see the liquid condensation. Okay, upon compressing. If you do this, and you're applying the same enormous pressure, I mean, the material didn't go anywhere. There's a lot of gases condensed in liquid, but now this is still, you don't see any meniscus. It's just a one-phase supercritical fluid whose density is halfway between the gas and the liquid. Can you imagine that? So people, the technical importance of supercritical fluid is, it's like a gas or liquid with a lot of surface area. So it's extremely useful for extraction purpose. So this, I guess, did you guys drink coffee this morning? Yeah. No? Did you know decaf coffee? Decaf coffee. There are some procedure they're using supercritical CO2. That's very actually effective to extract the caffeine out, and that's what they do. I guess I'm not talking about the process itself. You know, they used to decaf coffee. They used to use methylene chloride. Do you know what methylene chloride is? Chloroform. You don't want to drink it. This is a carcinogenic, right? I mean, it is so volatile, it will not stay there if you brew the one or anything they stripped off. It's still, they are using this very low boiling point, effective organic solvent to extract the caffeine out. But supercritical CO2 is pretty much benign, but it has its own challenges in it. So, okay, so let me write this about critical temperature of CO2 is 31 degrees C. That's why it is so attainable. Okay, so if you heat it up above a little bit over room temperature, you will see this one coming down, and the liquid is actually disappearing from here. Critical temperature of argon is actually minus 122 degrees C. That's actually pretty low too. So what that means is, if you want to liquefy to a liquid argon, you have to cool the gas below 120 degrees C, and then you compressing it. Now you have an opportunity to liquefy the argon. Otherwise, if you do it at room temperature, above the critical temperature, you bring your piston down and compressing it, nothing will happen. You will just see the supercritical fluid, the density is just proportional to the volume, and then that's the way that it's going to happen. Okay. One last comment on this is, I talked about Boyle temperature and the critical temperature, right? Do you think that which temperature is bigger. You remember that? This one is criteria for attractive interaction, right? This is the criteria for gas to liquefaction. Which one is more broader criteria for this? This one is kind of subclass of attractive interaction, right? There is attractive interaction doesn't mean that you can condense it down, right? So therefore, this is a TB is I think is a higher than TC, and this is a much more. Okay? So in a temperature scale, right? TC is there, TB is there. Okay, so this is where gas to liquid condensation happens. This is the temperature region that where you have a essentially. I mean this. I guess I should say this way, right? And this is the way attractive interaction can happen, right? So that's an idea that the different temperature that we use. Okay, the next one that I'm going to talk about is van der Waals gas. And this is the one I think that in chemistry 1, I think that Dr. Ma, he had this class, I think the van der Waals gas equation he wants to cover, but he sometimes will slip it out. So I don't know whether he put that back in yet or not, but this is my chance for you to do. And this one is actually very easy to understand and is very beautiful, and it has its own, something that is not good, but I think it captures a lot of things. So let's go back to the idea.